All right, hey guys, we are on lesson 12, page 99 in your book. Using graphs to compare relationships. First example here, it says find the product or quotient mentally. Can you look at those and see the answers? So remember what's nice about multiplying. If you look at this first example, if you have two things that can cross cancel, you can just pretty much cross them out. They're both a 2, so if I divide both 2's by 2, I get 1. So 1 times 1 and 3 times 1, that's just going to be a third. Second one, again, the 4's will just cancel out, and you'll be left with a 1 and 3 on top. That's still 1/3. How about dividing? Can you do a dividing problem in your head? Remember, when you do a dividing problem there, that's the same as multiplying by the reciprocal, and then, of course, that makes it pretty simple. Just 4 times 5 is 20. And same thing with the last one. Just multiply by the reciprocal. So you end up with 18 divided by 6, which is going to be 3. Or maybe you can cross cancel and see 9 divided by 3 is 3. However it takes you to get to 3, just remember, when you divide, the number behind the division sign is the one that gets flipped. All right, page 100. Diego, Lynn, and Mai went from the ticket booth to the bumper cars. Use each description to complete the table. Representing each person's journey. Sorry about that. All right, so I have 3 of them to do, and then I'm going to graph them, and then we're going to talk about the equations on the next page as well. So Diego left the ticket booth the same time as Tyler. Do you remember Tyler from lesson 11? This was Tyler's walk. We're going to come back to that. That's on page 92. Just make sure you know where that's at. But let's complete the table. So Diego left at the same time. So that means at 0, 0 is where he is starting. Because that's what Tyler started at, was at the origin. So if he made it there in 30 seconds, so he jogged ahead, made it quicker than Tyler did. I think he was 40 seconds if I remember correctly. So what is the number that goes here? Well, from 30 to 0, 15 would be half, right? What's halfway between 50 and 0? And that would be 25. And now how do I get the number next to the 1? How do I get the constant of proportionality? You can divide any of these numbers, 25 divided by 15 or 50 divided by 30. I'm going to do 50 divided by 30 because I can just get rid of the 0. Right, and I can divide it out and get a decimal, or I can write it as a fraction. So I'm just going to write it as 5/3. That is my constant of proportionality for Diego. That tells me his average speed in meters per second. Lynn leaves the ticket booth same time as Tyler. That means they start at 0, 0 again for Lynn. Lynn gets there in 20 seconds. Gets there even quicker than Diego. Again, halfway between 50 and 0 is 25. Halfway between 20 and 0 is 10. And then as a fraction again, I'm going to take 50 divided by 20, and I can just get rid of the zeros. So 5/2. If you prefer a decimal, you could write 2.5 there. Either one is fine. Maya is going to be a little different. Maya left the ticket booth 10 seconds, so she did not start at 0, 0. She left 10 seconds later, so her first number is going to be 10, because she gave them a head start, basically. It did take her 40 seconds to get there. I got there basically at the same time then, 40 seconds from when Tyler left. So what is between 40 and 10? What is halfway between those? And again, if you can't see it, you could just add them up and divide by 2, figure out the average. 40 plus 10 is 50, divided by 2 is 25. And then Maya's constant of proportionality would be 50 divided by 40, or 5 over 4. But is Maya's speed the same? Okay, so 25 divided by 25 would give me 1. 50 divided by 40 would give me 5 over 4. So 1 second into this, she is still at the starting point because she didn't leave for 10 seconds later. Okay, so I cannot put a number next to the 1 because it took her 10 seconds before she left anywhere. So she was still at the starting point 1 second later, 2 seconds later, 3 seconds later, all the way to 10 before she goes. All right, so on number 2 here, it says to graph everybody's, including Tyler's. So let's put Tyler's on there first. Again, that was page 92. We're going to copy that one over. So 40, 50, and connect it with the origin. Just make sure I get it right. 40 and 50. Okay, so I'm going to put a dot at 40 and 50. Just going to use my phone to connect them. You can use whatever you'd like. And I'm going to make a little note that that is Tyler. All right, now you can use a dotted line or a different color. I'm fortunate enough to have a couple pens here, so I'm going to use blue for Diego. So Diego was also at 0, 0. And his last point, let's see, is 15:25. And 30 and 50. So you can connect those. That is Diego. I'm going to use a red pen for Lynn. Using a chart on the previous page. Again, it's 0, 0, 10, 25, 20, 50. That is Lynn. And then I'm going to stay with red and for Maya, and I'll just do a dotted line for her. So 0 meters 10 seconds in, so she's starting over here. 10 seconds in, still at 0 meters, and then 25, 25. And 50 meters and 40 seconds. So it's going to meet up with Tyler. And I'm going to label that one as Maya. All right, so looking at that, who is moving the most quickly? Okay, who got there the quickest? Okay, well, Tyler made it in 50 seconds. Sorry, 40 seconds, 50 meters. Diego made it in 30. Lynn made it in 20. Mai made it in 40 seconds as well with a 10-second late start. So who do you think is moving the quickest? I'll give you a second to write down what you think. Okay, and I'm going to choose Lynn. How is that reflected in the graph? Well, I would say it is the steepest. Okay, and we can also kind of show by the speed. We could figure out everybody's speed. Like the Are You Ready here is asking for an equation, so we could compare that as well. And as far as Maya goes, basically it took her 30 seconds to get there. Right? Because after a 10-second head start, it still took her 40 to get there. That's 30 seconds. Lynn still made it in 20. So Lynn was still quicker. Okay, so we're going to write the equations for each. We're going to go Diego first. Diego's equation. So what number is next to the 1 for Diego? That would be 5/3 times time. You could do 1.6 repeating there if you want. If you wanted a decimal, that is Diego's time. Lynn, his distance equals 5/2t. That is Lynn's equation. And Maya equation is probably going to be the most difficult. The only thing different about Maya's time is that it's going to be 10 seconds later, so I'm going to put a t minus 10 there. And she still made it in, let's see, she still made it 50 meters and it took her 30 seconds, so 50/30 I'm going to use for my rate, or 5/3 again. So it's going to be the same as Diego's, except it's 10 seconds later. And Tyler's, I think we came up with Tyler's equation before. Tyler's was 1.25, or that would be 5/4 if we want to continue with the fractions. So Tyler's equation would be D equals 5/4 T. I probably shouldn't have a T there. I should just write Tyler. Or 1.25. Again, fraction or decimal, guys, it's completely up to you. Okay, so again, how to go from a chart to a graph to an equation. And again, the only trickier part there was that Maya left 10 seconds later, so that kind of threw a wrench into that problem a little bit. All right, next question. Number 1, page 102, it says a meteoroid Perseid 245 and asteroid X travel through the solar system. The graph shows the distance each traveled after a given point in time. So the question is, which one is traveling faster? Okay, and how do you know? So it does say explain, so of course we need to do that. Get rid of my pen because it appears to be bleeding through the pages there a little bit. So if I compare at the same time, all right, so I'm going to compare at the same time, so it doesn't really matter where you draw a line. And that can represent any amount of time. Let's say it represents an hour. Okay, so this represents how far Perseid 245 traveled, because that's distance. And this dot would represent how far asteroid X traveled. Okay, so at the same time, I'm looking at the same time, which one traveled further? And hopefully you say that that has to be asteroid X, because it's a higher distance. The higher I go, the higher the distance, the greater the distance. So who traveled faster? Asteroid X. Explain, how do you know? When comparing the same time, asteroid X traveled a greater distance. Okay, number 2, again, a similar type of problem. The graph is showing different lengths of rope, 2 types of rope actually, cotton or nylon. Which one will be longer? Which one can you get more for $1? Okay, so now $1 is my constant. $1 is the same for both ropes. Okay, so this is my price. So instead of drawing a line this way, my length is not constant. I'm going to draw a line this way from the price. So wherever you think $1 would be, again, it doesn't matter. I'm going to say $1 would be about right here. $1. Now I'm comparing the cotton and the nylon on that line I drew. So for $1, which one can you get a longer length for? Again, the blue one here represents cotton. The black line represents nylon. So here's how much you would get for cotton in length. Here's how much you would get for nylon in length. And it looks like the length is getting bigger as we go to the right. So which one can you get a longer rope? Your answer is nylon. Okay. The graph shows that for a constant price, I can receive a longer piece of nylon. Okay, summary on the next page again, comparing two different stores. Looks like this one is raspberry or blueberry prices, store A or store B. So which one, for instance, would be cheaper? Well, it looks like this black dot would represent 1 pound, and the Y coordinate would represent cost. So 1 pound is $6 at store A, while 1 pound is $4 at store B. So where are you going to go shop at? Hopefully at store B for $2 a pound cheaper. All right, your assignment, guys. First one is to match each equation to its graph. So each one of these has a match below it. I'll give you a little hint. The bigger the first number, up 2 over 1, up 2 over 1. Okay, the bigger the first number in the equation, the constant of proportionality, the steeper your graph will be. So whichever one of those numbers is the biggest, is going to be the steepest. Whichever one is the smallest will be the flattest. Okay, and another thing you could do is you could plug in points. For instance, with this first one, let's say I plug in 1. What's 2 times 1? And you'd get 2. So that point would be on the graph. Now if I plug in 2, what's 2 times 2? 2 times 2 is 4, so those 2 points would be on this graph. Okay, so that's another helping hint for you for that one. Okay, the next question. Graph shows some data from a coffee shop menu of the graphs shown in dollars and drink volume in ounces. And one graph is going to show you calories. Okay, so one of them is cost and one of them is calories. Both of them are going to be volume of drinks. You can see the volume of drinks. So do you think it's going to cost you $50, $100, $150 for coffee? Or is it going to cost you $1 or $2 or $3 or $4 based on your drink? Okay, so again, one is calories and one is cost. So hopefully you're saying that your coffee is in the $1 to $6 range and not the $50 to $350 range. That would be some expensive coffee. So I'm already going to label this one cost. This one I'm going to label calories. And then from there, you should be able to answer the rest of the question. Question number 3, you're actually going to draw a graph with 2 lines. I guess it doesn't really matter where you put it. You can just draw a little sketch down here, your X and your Y axes. When you do that, let's be sure let's do time on the bottom. That'll be in minutes. And this will be distance on the side. That'll be in kilometers. And then give it a title. Graph 2 points. Graph it for Lynn. Graph it for Andre. and then answer the questions on the next page as well. So it is only 3 questions, page 104 to 106 for tomorrow.